morning. Now we will start discussion on a new module, tutorial on anaerobic digestion. In previous module we have discussed on anaerobic digestion processes and the production of biogas through these anaerobic digestion methods. In this module we will discuss some numerical problems and we will solve it. So, the statement of the first problem is, in a high rate biogas plant, food waste is anaerobically digested to produce biogas. The slurry contains 8% of solid food grains. The elemental composition of the food grains on dry basis is carbon 58%, hydrogen 8%, oxygen 26%, nitrogen 8% on mass basis. Around 80% of the food grains are converted to biogas and all the converted hydrogen forms methane. If the flow rate of the slurry is 4500 liter per day, calculate the rate of biogas, that is CO2 plus CH4 production. So, this is the problem statement. Now, we have to solve it. So, if we see the problem statement, we have given some information and one basis is given here, that is 4500 liter per day of slurry handling. So, we are handling 4500 liter per day of slurry. It is also given that 8% solid is present in the slurry. So, we can calculate how much solid is present in the slurry. Then the percentage carbon, hydrogen, oxygen, nitrogen is also given. So, we can get the amount of elements carbon, hydrogen, oxygen, nitrogen present in the slurry. Then it is around 80% of the food grains are converted. So, at 80% of the food grain is converted, so all these components will also be converted 80%, we can assume. Then we will see another condition is given, that all hydrogen forms methane, all converted hydrogen forms methane. So, at first we will calculate how much methane is produced on the basis of hydrogen conversion. Then from the back calculation we will get the carbon used for this methane production, and then we will get total carbon and how much carbon dioxide is remaining, and that will be used for carbon dioxide production. So, these are the methods which we will use to solve the problem. So, we have basis 4500 liter per day, this is our basis. If we assume the density is 1 kg per liter, then the mass is equal to 4500 kg. 8% is slurry. So, slurry solid is equal to 4500 into 0.08. So, that is equal to, we are getting 360 kg. So, that is equal to 360 kg. Then what is our carbon? Carbon is 58%, hydrogen is 8% and oxygen is 26%, and then what is nitrogen? That is also 8%. So, in the solid how much carbon is present? 360 into 0.58, 360 into 0.58. So, that is equal to 208.8 kg. So, what is our hydrogen? 360 into 0.08, 360 into 0.08. So, that is equal to 28.8 kg. Then what is our oxygen? Oxygen is 26%. So, that will be 360 into 0.26 that kg, and that is equal to, we are getting 93.6. And what is our nitrogen? 360 into 0.08, so 28.8 kg. So, these are the elemental composition or amount of different components present in the slurry. Then what we will do? 80% is conversion, 80% conversion. So, carbon how much converted? 280.8 into 0.8, 80%. So, that is equal to how much? That is equal to 167.04. Then how much hydrogen is coming? 28.8 into 0.8, 28.8 into 0.8. So, that is equal to 23.04. This is equal to 208, this is equal to 208.8. So, this is. So, now how much oxygen is converted? That is equal to 93.6 into 0.8, 93.6 into 0.8. So, that is equal to coming 74.88 kg, 74.88 kg. Okay. Now, what we will do? We have to find out how much methane is produced, how much hydrogen is converted. We have got 23.04 kg. Now, how much methane will be produced? CH4 12 plus 4, that is equal to 16. So, 12 gram carbon will give 16 gram of methane, that is why, and 4 gram of hydrogen will give us 16 gram of methane. So, how much methane is produced? 16 divided by 4 into how much this conversion is. So, how much it is? 23.04. So, into 23.04. So, that is equal to 4 and that is equal to 92.16 kg, 92.16 kg. So, that is equal to 92.16 kg. In terms of mole, we can get this is divided by 16. So, that is equivalent to, we are getting 5.76 kilomole, 5.76 kilomole. So, this is the methane we are getting. Now, how much carbon is used for the production of this amount of methane? We can get carbon used for methane production, that is equal to how much? 92.16 into 12 by 16, 92.16 into 12 by 16, that is equal to 69.12. So, how much carbon we had? 167.04 conversion and 69.12 is for methane production. The rest carbon will be used for the production of carbon dioxide. So, carbon used for carbon dioxide production. So, carbon used for CO2 production is equal to how much? We will be getting 167.04 minus 69.12 kg, that is equal to 97.92 kg, that is equal to 97.92 kg. Then how much CO2 is produced? So, CO2 produced is equal to 97.92 into 44 divided by 12, 44 divided by 12 and that is equal to 359.04, 359.04 kg. So, 359.04 kg in how many moles we can get is equal to divided by 44. So, it will be giving us equal to 8.16 kilomole. So, we have now got how much CO2 and how much CH4 is produced. Now, so total CH4 and CO2 is equal to how much? We are getting 92.16 kg plus 359.04 kg, or total is equal to 451.2 kg, 451.2 kg in terms of mass, but in terms of moles 5.76 kilomole, and here we are getting that is equal to 8.16 kilomole. So, these two, so in terms of kilomole that is equal to 5.76 plus 8.16. So, we are getting total is equal to 13.92 kilomole, this kilomole. So, now the first problem is solved. Now, we will see the problem number 2. So, in this problem the statement is, in the above plant the effluent from the digester is used for the production of manure through composting. If 75% of organic compounds present in the effluent are converted to manure, what is the rate of manure production? That means, we have got 80% organics is converted to gas. So, remaining 20% is present in this, in the slurry. So, we had 360 kg, of solids. So, out of this 360 kg 20% will be available in the slurry after biogas production. So, the solids present is equal to, here organic compounds present in the digested effluents is 360 into 0.2, that is equal to 72 kg, and 75% of it is converted to manure. So, 75% means 72 into 0.75, that will be 54 kg per day. So, this will be the manure production. Here we are assuming that there is no mass loss or gain due to microbial activities. So, this is the solution of this problem. Now, we will solve problem number 3. The statement is, a family having 15 cows of body weight 200 kg each and 20 chicken of body weight 1.5 kg each wants to set up a biogas production plant. What should be the volume of the anaerobic digestion unit suitable for this application, and mention volume of various zones of the unit. Assume discharge per day of each cow is 10 kg and total solid, that is TS value is 16% of the discharge. Similarly, for chicken these values are 0.1 kg per day and 20% respectively. HRT hydraulic retention time is 40 days. So, daily gas production rate is 0.28 meter cube per kg TS per day or 0.4 meter cube per digester volume per day. If total volume of the digestion unit, that is V, is related with the diameter of the cylindrical portion as D is equal to 1.3078 V to the power 1/3, and calculate the height of the cylindrical part of the unit, assuming its volume as V3 is equal to 0.3142 d to the power cube. Also calculate the volume of sludge zone, active digestion zone, gas collection zone and gas storage zone. So, this is already discussed various zones of the unit. So, this is the statement. So, we have given the number of cows and number of chickens available in the family, and discharge per cow and per chicken it is given, and the K values are also given, that which will be used, and it is also given the TS present in these two discharges. V and D relation is also given. So, if we have say one digestion plant So, it is given. So, this is a sludge zone, V sludge, this is the gas collection, this is a storage, and this is active zone, the VD, and this is your cylindrical portion, this is our H, and this is equal to V3, this is equal to, the cylindrical portion is equal to V3. Now, V3 is 0.1342 d to the power cube and d is equal to 1.3078 is V to the power half. This V is equal to V call collection plus VST plus gas storage GST plus VD plus V sludge, and this V3 is equal to this portion. If this is our height, this is our lower portion, say this is our height. So, this is our V3, this portion is our V3. Okay. So, these are given here. So, we have to calculate the value of VSL, VD, VST, V call. Now, what is our information given here? The total sludge, how much sludge we are getting? We have 15 number of cows. So, 15 into 10 kg per day, 10 kg per day, plus we have 20 number of chicken. So, we have 20 number of chicken and it has 0.1 kg, 0.1 kg. So, we are having, so this is your 0.1 kg. So, we are getting 150 20 into 0.1 kg. So, that is equal to 150 plus 2 152 kg. So, this is our discharge per day. So, the chicken, the values are 0.1 kg per day. So, this is the similar, the chicken discharge is 0.1 kg. So, we have 20 chicken. So, that is using 0.1 kg per day, that is why 20 into 0.1. So, that is why 20 into 0.1 and then 15 into 20, 10, that is equal to 150 plus 2. So, 152 kg is the total discharge. Next will be TS in the total discharge. What will be the TS? That is equal to 150 into 16%, 0.16, that is for cow dung, and this is for chicken, that is 2 into 0.2, that is equal to 20%, that is 2 kg is coming from the chicken waste. So, and the solid content is 20%. So, 2 into 0.2, that is equal to 24.4. So, 150 into 0.16 plus 2 into 0.2, that is equal to 24.4 kg. So, this is the coming. So, 0.16 means 16% of TS in the cow dung, 0.2 means 20% of TS in the chicken waste. Now, what is our condition? The slurry will be having 8% TS. So, 8% TS if the slurry has, so 8 kg of TS is required to make 100 kg slurry, since the 8% slurry is required. So, 24.4 kg is produced daily. So, what will be the volume of the slurry to accommodate this 24.4 kg of TS? So, that is equal to 100 divided by 8 into 24.4, because to accommodate h kg we need 100 kg total slurry weight. If the density is equal to 1, so 100 liter. So, 100 divided by 8 into 24.4, that is equal to 305 kg slurry, that is 305 liter, when we are assuming that density is equal to 1 kg per liter. Now, how much material is produced by this, the cow and your chicken, that is equal to 152 kg. So, how much water we need to add? So, water addition is equal to, water addition is equal to 305 minus 152 minus 152. So, that is equal to 153 kg water we have to add. So, 153 kg water we have to add. Now, what will be the gas storage volume? As we have discussed in the previous module of anaerobic digestion, that VST plus this VGST gas storage plus VD, that is equal to 80% of total volume. This is our assumption, that 80% of this, and this is equal to slurry feeding rate into HRT. So, this is equal to also VGST plus VD, that is equal to Q into HRT. What is the retention time, what is the feeding rate, what is the feeding and what is the retention time? If we multiply this, we will get VGST plus VD. We have discussed in the anaerobic digestion module. So, here what is the slurry feeding rate? Slurry feeding rate is our 305 liter per day into HRT. HRT is equal to how much? That is equal to, HRT is 40 days. So, we have to multiply it. So, we multiply it 40 into 305. So, it is coming 12,200 liter. So, VGST plus VD, we are getting VGST plus VD, we are getting how much? 305 into 40, that is equal to 12200 liter or 12.2 meter cube. We can get 12.2 meter cube. And another we have discussed again, that VGST plus, that is equal to 0.8 into V. So, what will be VGST plus VD is equal to 0.8 into V. So, what is V? V is equal to 12.2 divided by 0.8. So, that is equal to 15.25 meter cube. So, that is equal to 15.25 meter cube. So, now we have got the total volume of this, that is equal to 15.25 meter cube. Now, we will have to get the different zones. Now, one information is given, that D is equal to 1, what is D? This is the D. The diameter of this cylindrical part is equal to D, and that D is equal to 1.3078 into V to the power 1/3. So, what is the D? D is equal to, we can getting here 1.3078 into 15.25 to the power 1/3, and that is equal to how much? We are getting 3.24 meter. So, 3.24 meter. So, this is equal to 3.24 meter, that is equal to, and then what is V3? We will put this D value here. So, 0.3142 into 3.24 cube. Now, another important information which we have got here, that what is V3? V3 we are getting from this equation. Another is, this is V3, that is cylindrical part. So, pi d square by 4 into h, that is also the V3. So, here we will put, that is equal to pi d square by 4 into h, that is equal to 0.3142 into 3.24 to the power cube, that is equal to D. We can write it here D also, D cube. Now, D square D cube cancel. So, H is equal to 0.3142 D into 4 divided by pi, and so H is equal to 1.29 meter. So, by this calculation we are getting H is equal to 1.29 meter. Now, we have got the value of H. Now, we need to calculate the V collection. What is the V collection? That is 5% of V. What is sludge collection? Sludge volume, that is equal to 15% of V, 15% of V. Okay. So, now we have got the V value. So, what will be V? V collection is equal to 0.05 into 15.25, and that is equal to 0.7625 meter cube. Then what is our V sludge? that is equal to 0.15 into 15.25 and that is equal to 2.288 meter cube. So, that is equal to 2.288 meter cube. So, we have got this one, we have got this one, okay, we have to calculate this and this. Now, in the previous module we had seen that VGST come here. So, VGST is equal to 0.5 into VGST plus VD plus VSL into K. What is this K? K is nothing but 0.4, that is the meter cube per meter gas produced, meter cube of gas produced per meter cube of volume of reactor per day. So, that is equal to 0.5 into VGST plus VDS plus V sludge into 0.4. Now, what is VGST plus VD plus V sludge plus VCOL, that is equal to total volume. Total volume is equal to VSL plus VD plus VGST plus VCOL, V collection. So, these 3 is equal to, we can get equal to V minus V collection, and this V is equal to 15.25 and V collection is equal to 0.7625. So, these two, it is becoming this one 15.25 into 0.7625. So, this into 0.5 into 0.4, that is giving 2.898 meter cube. So, that is VGST we are getting now. Now, alternatively we also know that VGST can be calculated on other thumb rule, that is 50% of daily gas yield, that is 0.5 into TS or total solid into gas production rate, that is meter cube per kg TS per day. So, this value is equal to 0.28 as given in the statement. So, 0.25 TS equal to 24.4 as per the statement given, we have calculated, and then this equal to 3.416 meter cube. So, VGST one formula is giving us 3.416 meter cube, another formula is giving us 2.898 meter cube. So, we have to be conservative. So, we will be taking the larger value. So, 3.416 meter cube. So, VGST equal to 3.416 meter cube. So, then what is VD? VD is equal to V minus VGST minus VSL minus VCOL. So, everything we have got, that is 15.25, we have got this one, this one, this one and this one. So, as seen here. So, 15.25 minus 3.416 minus 0.763 minus 2.288. So, we are getting 8.738 meter cube. So, now we have got the values of all the zones VSL, VD, VGST and VCOL as well as the total volume. So, the problem is solved. So, up to this in this module. So, thank you very much.